Okay, so today we're going to look at this part 4 for fractions. It's the final thing I want to teach you about fractions specifically. So last time we talked about both multiplication and division of fractions. Yes, Phoenix? I just started and you'll have to wait, okay? So today we want to move forward and go from where we left off, okay? So let's start with some strange looking fractions, okay? So far in this unit, this is what we should be able to do. Understand what a fraction is, simplify a fraction. These are the kind of things you can expect are going to come up to make simpler numbers. Compare fractions by creating a common denominator. Add or subtract two fractions, multiply or divide two fractions. So today we're going to move forward from there and look at some different types of fractions. Now, we did this earlier, but let's start putting some fractions on a number line, okay? If we take, for example, the fraction 1 over 2, or a half, and then we look at this strange looking fraction, 11 over 2, there's a way we can define these fractions. Ones that are between 0 and 1 are called proper fractions, and ones that are above 1 are called improper fractions, okay? Basically, the definition is an improper fraction is a fraction where the top number is larger than the bottom number, okay? Or the numerator is larger than the denominator, okay? This is strange because we don't, if we think of the way I originally defined fractions as they were parts of something, how can you have parts of something where it's bigger than 1, okay? So improper fractions are just another way to write numbers with fractional parts. Okay. Now we also saw this when we traveled the number line, right? If we start at 1 over 20, we go to 2 over 20, 3 over 20, eventually getting all the way to 20 over 20, which is basically 1. And then we keep going the other way, going all the way over here to 40 over 20, okay? This again shows this idea of some fractions getting the top number getting larger than the bottom number. In addition to improper fractions, you should also know about what are called mixed fractions. What a mixed fraction is, it's a mix of a whole number, like 6, and then the fraction part, 4 over 5. This is why it's called a mixed fraction. Sometimes it's called a mixed number. Doesn't matter. I like to call it a mixed fraction because that's what it is, okay? Which is literally a mix of numbers and fractions, okay? Good news. Improper fractions and mixed fractions are the same thing. They are identical, okay? Just the way you write them is different, and we want to know how we can sort of change from one to the other, convert them. So that's what we're going to look at. Okay, so as I said, improper fractions are where the numerator, the top number, is larger than the bottom number, or the denominator. It's the same as working with regular fractions. So when you do math with them, you do the exact same stuff you would do when you do regular fractions. You can simplify them, you can compare them, you can add them, you can subtract them. An improper fraction is still a fraction. So all the rules I've taught you about fractions up to this point also work with improper fractions. You do them exactly the same way. Let me show you an example, okay? So if I said simplify that improper fraction, okay? Remember, the way you simplify something is you take each number and create factors for it. So the factors of 12 would be, well, I divide it by the number, and if I get an even number like 2, then it's a factor. So 6 is a factor. I divide 12 by 5 and I get 2.4. Well, that's not an even number, so 5 is not a factor. 12 divided by 4 is 3, so 4 is a factor. 3 is a factor, and 2 is a factor. So I've got a set of factors for 12. I do the same thing with 9. Divided by 6, I get 1.5, not a factor. Divided by 5, not a factor. 4, not a factor, but 3 is a factor. So what I then found is a common factor for both 9 and 12. In this case, it was 3. Right? 3 was the only one that appeared in both lists. So now that I have a common factor, I can use it to divide both numbers. Divide by 3, divide this one by 3, and I get 4 over 3. That's how you create the simplified fraction. We did this way back at the beginning. Okay? You had some practice on that in the worksheets. Simplifying is kind of one of the harder things to do with fractions. Notice that it's still improper. The top number is still larger than the bottom, but it's a lot simpler than 12 over 9. Okay? Now, can I subtract them? Here's two improper fractions. 20 over 5 minus 4 over 3. Absolutely. I just use the same techniques I taught you a couple lessons ago. One, I need a common denominator. Once I have a common denominator, I can move on. To get a common denominator, I get the simplest denominator by just multiplying 5 times 3. And I get 15 on both. To get to 15, I multiplied this by 3, so I multiply the top by 3, and I get 60 over 15. To get this one to 15, I multiplied by 5, so I multiply the top by 5, and I get 20 over 15. So in reality, these two fractions can be converted into 60 over 15 and 20 over 15, and then I just straight up subtract them. 60 minus 20 is 40 over 15, and I'm done. So I can do regular adding and subtracting with improper fractions, no problem. Now that could also be simplified. I'm not going to, but you could also simplify it from there. What about multiplication and division? Well, let's try one. Here's two improper fractions. 20 over 3, 15 over 4. I'm going to divide them. Some of you were doing this yesterday. So the way you divide, remember the step. Step 1, flip the second fraction. So 15 over 4 becomes 4 over 15. And once you flip it, division becomes multiplication. Now you straight up multiply. 20 times 4, 3 times 15. I get 80 over 45, and I'm done. Okay? It's still improper. Notice this number is larger than that number. But my point was, you can work with improper fractions the same way you work with regular fractions. Just because the top number is larger doesn't mean you don't do the same stuff. Okay? However, with mixed fractions, you got a little different choice there. So when you got something like 5.5, how can I do stuff with that? And that, by the way, was on your diagnostic test. You had a few questions where you had to work with mixed fractions, and a lot of you got that wrong. You didn't know how to do those, okay? Well, basically, it's the same as working with improper fractions, okay? You can do all the multiplication, dividing, and all that, but my advice would be you can convert this to an improper fraction and then work with it. So that's what I'm going to show you how to do. To convert a mixed fraction to an improper fraction, step 1, multiply the denominator by the whole number. Step 2, add the numerator to that value. Step 3, place that value as the new numerator. And step 4, keep the original denominator. So now I'm going to show you this in an example. So here's the mixed fraction 6 2/3. And I made a nice little animation to demonstrate this for you. Okay, so let's watch this. Here's how it goes. Phoenix. Step 1, multiply the denominator by the whole number portion. So 6 times 3, I get 18. Step 2, take that answer, 18, and add it to the numerator. 18 plus 2, 20. That number becomes the new numerator. So it becomes 20. The denominator just stays the same. I don't change the denominator. So 6 and 2 over 3 is the same as 20 over 3. Now that it's an improper, I can do whatever I want with it. I can add it to stuff, I can multiply, divide. So again, that way to convert one to the other, I think really important. Okay. There are times you have to go back the other way. To convert an improper fraction to a mixed fraction, I just divide them. I do a division of the numerator by the denominator, but I do it using long division. I don't use a calculator for this. I use long division. That answer to that division becomes the whole number portion, and the remainder of that division becomes the new numerator. So you have to know how to do long division, and again, some of you were struggling with that in the diagnostic. Okay? So let's watch this one. I'm going to do 32 over 5. Okay? So here's how you would do this. You turn this into a division question by taking the 32 and placing it here, and taking the 5 and placing it here. Now we have a division question. 32 divided by 5. Okay? That's step 1. Step 2. Now we perform that division. So I'd go, okay, 6 goes into 32 6 times. 6 times 5 is 30. Remainder 2. Remember remainders? We stop at the remainder. We don't keep going. We don't keep going into anything else. We just do that. 5 goes into 32 6 times. 6 times 5 is 30. There's 2 left over. What's important now is these two numbers. the answer and the remainder. The answer, 6, becomes the whole number portion. The remainder becomes the new numerator. And the denominator stays the same. The denominator doesn't change. So the 5 stays where it is. And we're done. Okay? So this is another 4-step process to turn something like 32 over 5 into 6 2/5. Okay? We saw the previous one, or I could turn 6 2/5 into 32 over 5. And you should be able to do that back and forth, one to the other, okay, to make it easier for you to work with based on what kind of question you're getting in math. All right, let's wrap it up. The takeaway from today, you need to know these two terms. An improper fraction is a fraction where the top number, the numerator, is larger than the bottom number, the denominator. A mixed fraction is literally a mix of whole numbers and fractions. There are 2 methods here that you need to know. Today I'm giving you 2. 1, to convert mixed fractions into improper fractions, and then 2, to convert improper fractions into mixed fractions. So you can go one way or the other. You can change them back and forth. Okay? All right, let's try one example before I wrap up today. Okay, give me a improper fraction. Nothing too crazy. No, that wouldn't be improper. 30 over 5. Okay. Okay? Now, I could work with that. As an improper fraction, if I needed to, I could simplify it. I could add it to another fraction. I could divide it, multiply it. But what if I wanted it to be a mixed fraction? The process, again, is I turn this into a division question. The 5 goes here. The 30 goes here. And I turn it into a division question. All right? Let's try it. 5 into 30. Okay. 5 goes into 30 how many times? And 6 times 5 is 30. So our remainder is 0. So the answer then, this number right here, 6, becomes the whole number portion. What's the fraction portion? No. The fraction portion becomes whatever is left over as a remainder, 0, over the original 5. But the weird thing about a fraction like that with a 0 in it, does anyone know? It's 0. So it's basically gone. There's no need to write this. Okay, but let's modify this slightly. You chose 2 numbers that just happen to work out really well. Let's change it up a little bit. Instead of 5 and 30, let's pick numbers that are a little nastier. Pick me a different number. That's great, okay? Then you use your method. Okay, let's pick 41. And on the bottom, let's put a 3. Those aren't going to work out as nicely, okay? But the same thing applies. The 3 goes here. The 41 goes here. Okay? Let's redo that division now, okay? And watch how this goes. So 41 divided by 3. How many times does 3 go into 41? Well, we can do this a little bit longer. We can say 3 goes into 4 one time. Bring down the 1. 3 goes into 11 3 times. Gives us 9 with a remainder of 2. Okay? So 3 goes into 41 13 times. In other words, 3 times 13. And so we're done. What we need now is these 2 numbers. Okay? This one and this one. Okay? They're important to us. Because what the 13 does is it becomes our whole number portion. What that 2 becomes is it becomes our new numerator. And our denominator stays the same. It never changed. That denominator stays where it was. Okay? Now let's test that. Let's take 13 2/3 and try turning it back into an improper fraction. it should turn out to be the same. So we got 13 and 2/3. Okay, so remember, the process for working with this one is you take the bottom number and multiply it or times it by the whole number. So what's 13 times 3? Anyone? 60. No, not 60. 13 times 3. 39. So I get 39, okay? But I'm not done yet. Once I've done that, I then take that number and add it to that number. Becomes 41, that's right. And the denominator stays the same. And we're done. And notice 41 over 3 is exactly the same as where we started. We went from there to an improper, or to a mixed fraction, and then from a mixed fraction back to an improper fraction. And that's all I wanted to get out for today, is that concept with you guys.